Alright, so we got page 78, 79 that we're going to do today. And then you're going to watch a couple videos on your own. So, today we're looking at sine, cosine, tangent, and trigonometry values in your journal. So first thing you might want to do is trim down this paper. And then on this one, I just kind of cut off these little pieces here. Alright, so what we're looking at is trigonometry. This is not all of the trig functions. This is just the basic sine, cosine, and tangent. There's also cosecant, cotangent. There's other ones that you will learn later on if you take pre-cal and calculus. But this is just like the basics that we need to know for geometry. So on the front, I'm just going to show you what each formula would be for each one. Of course, we have a calculator, so that helps us out a lot. But let's name this first triangle, triangle ABC. Notice that all of these triangles are right triangles. Okay, so right now we're only learning how to use the trig functions with right triangles. So, if I'm finding the sine of one of the angles, let's say I'm finding the sine of angle A. Okay, I'm going to, first of all, I need to realize that this is my hypotenuse. Okay? Always, the hypotenuse is always going to be across from that right angle. Okay? Notice over here to the side we see SOH, like S-O-H. What that means is that sine is the same as opposite over hypotenuse. So, the opposite side of angle A would be this side down here. So the formula for sine is always going to be opposite over hypotenuse. So we say so. We abbreviate with this to help us remember that. Okay? And this will make sense once we start actually plugging in numbers. You'll see what I mean by that. Cosine is going to be different. So notice here it says co. This A stands for adjacent. The H still stands for hypotenuse. So again, we're going to name our triangle ABC. Now, if I'm finding the cosine of angle A, then my formula is going to look different. Okay? So again, my hypotenuse is still here because it's still across from the right angle. The A stands for adjacent. What that means is right next to. So the side that is right next to angle A would be this side right here. It can't be this side because that's already called my hypotenuse. So over here I'm going to write an abbreviation for the word adjacent. So the cosine of A is found by putting the adjacent side over the hypotenuse. The last one is called tangent. Okay, so TOA. Alright, so O over A, that would be opposite over adjacent. So again, I'm going to use the same angle to show the difference. This is again triangle ABC. If I want to find the tangent of angle A, it would be the opposite side over the adjacent side. So the tangent is found by putting the opposite over the adjacent like that. So what people normally say to memorize what these are is SOHCAHTOA. Kind of sounds like an Indian name or something. But that, if you put them all together, that's what it says, SOHCAHTOA. So that helps you remember. Sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? So we are going to open this up. We have two examples for sine. So these are going to be two different things here. The first one on this side is finding the sine of the angles. Okay, so if it says sine of A, I'm thinking angle A. So again, the sine of A is going to be opposite over hypotenuse. What is my hypotenuse in this problem? 10. Very good. So the hypotenuse is going to be the same on both equations because the hypotenuse does not change. However, the opposite side is going to be different. The opposite side of angle A is going to be what number? 6. Very good. So my answer is going to be opposite, which is 6, over hypotenuse, which is 10. Okay? And that would be your answer. Normally, I would ask you to simplify that, which we would simplify that down to 3 over 5. So your answer would simply just be 3 over 5. So it's really not hard. I know these words are kind of different, so it makes it sound kind of difficult, but it really isn't once you know those formulas. So the sine of B is going to be different. Okay, so this is angle B, and we're going to put the opposite side, which is what number? 8, over the hypotenuse. So my answer would be 8 over 10, which is the same as 4 over 5. Okay, not bad, right? All right, now, over here, this is going to be different, okay? So, we don't only use sine, cosine, and tangent to find the measure of angles. We use it to also find the measurement of the sides, okay? So, on this problem, we are going to solve for side BC, which is here. We're going to solve for that first, okay? So, again, this is my hypotenuse. We need to remember that. So sine is you can only find sine of an angle, all right? So if I'm going to use the angle that's given, I'm going to use 21. So I'm going to set it up as sine of 21 degrees because I already know that that's the degree measurement. So it's a little bit different than what we did here. Here we did not know the angle. Here we do know the angle, okay? So what I'm going to do here is I'm going to put the opposite side, which is what? Which is AC, actually. So this would be my opposite side. And I'm just going to name that X because I don't know what this measurement is right now. So X, and then the hypotenuse would be 9. So that's how I would set it up. Okay, instead of putting the variable over here, I'm putting it in the actual fraction because I don't know the answer yet. So what you would do here is, first of all, you would cancel out the 9. So if I want to cancel out this 9, I'm going to multiply by 9 over 1. Okay, so I would cancel that out, and then over here I'm going to do the same thing. You got to do the same thing to both sides. So my new equation is going to be 9 sine 21 equals X. Alright, so with your calculators, I'm going to show you how to solve these problems. Okay, so I have a calculator here. I'm going to show you how to do that. So on my calculator, I'm going to type in 9, okay? And then I'm going to type in, if you look down here, you see the word trig, right? So you're going to click trig. Right now we're doing sine. Notice that look at all these other trigonometry functions. We're not doing those. We're going to do sine. And then we're going to type in 21. And we need to make sure that we're typing in a degree symbol. Okay? So the way we do a degree symbol is we press Control and then we press this book right here. Okay? Notice there's a bunch of different little symbols here. Mine is already on the degree symbol, so I'm going to click degrees, and that's all I have to do. Once I do that, I'm going to press enter, and I have my answer. So my answer here would be 3.22531, which normally it's going to ask us to round to the nearest hundredth, nearest tenth. Right now we'll round to the nearest hundredth. So if I do that, then X would equal 3.225 23. So that's going to be my answer for segment AC. Okay, so I have 3.23. That's going to be the answer down here. Now, there's two different ways to do this. You could do Pythagorean theorem, or you could use another trig formula. On this one, we can just use Pythagorean theorem because we've been doing that. So the way we're going to solve for side BC is we're going to use our side measurements now. Okay? So again, remember, a squared plus b squared is c squared. I'm going to do this in a different color so we understand that this is something totally different. So A, we don't know. We're going to use this number here to help us for B. And then c squared would be 9 squared. Okay, remember, c is always my hypotenuse. So what I'm going to do now is I'm going to type in 3.23. I'm going to square it. And then I'm going to do 9 squared, which is 81. And I don't know what a squared is. Alright, so my next step would be to subtract, which we've already done this before, so hopefully this looks familiar to y'all. And I get my what a squared is equal to. Your last step would be to find the square root of that answer. So I would do control, and then I would do answer. And my answer is 8.4. So A is approximately 8.4, and that gives me my last answer there. So up here at the top we use sine to figure out one side, and then at the bottom we use Pythagorean theorem to find the next answer. Alright, so that's sine. That's just one example for sine for each one. So now we're looking at cosine. No, when I'm done you can. Alright, so I have cosine. So cosine is adjacent over hypotenuse. Alright, so if I'm finding the cosine of B, which side is my hypotenuse? 20, very good. And that means that this is going to be my adjacent because it's right next to it. Okay? So this is my adjacent. So if I'm doing adjacent over hypotenuse, my answer would be, for B, which is down here, would be 12 over 20. If I simplify that, I get 3 over 5. So the cosine of A is going to be different. The cosine of A is going to be adjacent over hypotenuse. What is the adjacent side for angle A? 16, because it's right next to it. So we would do 16 over the hypotenuse, which is 20, which reduces to 4 over 5. Okay, so these are easy. These are the easy ones where you're just finding the side measurements or the angle measurements. Okay, on here we're finding the sides. These are a little bit more difficult. So if I am trying to figure out one of these sides, I'm going to start by using the information that's given. The information that's given is the angle of C and a side measurement here. So I know that this is my hypotenuse. So that's going to help me out. And this is the adjacent side to this angle, to angle C. It's right next to it. So I'm going to start off by doing the cosine of 37. So instead of writing cosine A, I'm going to write cosine 37 degrees. And I'm going to put the adjacent side over the hypotenuse. So do I know what the adjacent side is right now? No. So that's going to be labeled as x. The hypotenuse is going to be 13. So this is kind of like what we set up here at the top. Okay? So on this one, I'm going to multiply both sides by what number? 13. Very good. Bless you. So again, you have to cancel out that fraction on that side for this to work. So when I cancel that out, my new equation is going to be 13 cosine 37. So now you're going to, again, get your calculator. And what we would type in here would be 13. Again, you would go to your trig function. You would go to cosine this time. And you would type in 37. And then again, you would find that degree symbol. Okay, if you don't type in the degree symbol, it might not come out correct. So you need to make sure that you're doing that. So when I do that, I get my answer. X is 10.38. Alright, so last thing you would do is you need to find the measurement of AB. We found BC, we need to find what AB is. So again, you're using Pythagorean theorem to find this. If I'm setting up A squared plus B squared is C squared, what is my C squared? 13, very good, because that's my hypotenuse. So we would do 10.38 squared plus B squared equals 13 squared. Alright, so I'm going to square both sides, both numbers. So 10.38 squared and then 13 squared. What's my next step here? Subtract. Very good. So I'm going to subtract. That means that B squared is the same as 61.26. And then your last step would be to find the square root of that. Which would be about 7.83. So that gives you AB measurement there. Alright, last example here. Okay, this is tangent. So tangent, I'm just put this calculator over here, is opposite over adjacent. Okay? So the tangent of A, this is A, the opposite would be 15. And what would my adjacent side be? It would be 20, yes. We would not count 25 as the adjacent because that is still your hypotenuse. So my answer would be 3 over 4. Okay, and then the tangent of B is going to again be the opposite, which is 20, over the adjacent, which again would not be 25. That's your hypotenuse. It would be 15. So this would actually be 4 over 3, which is fine. It's okay if it's improper. Alright, so on here we're finding the missing sides. We're given a 20, we're given 50 degrees. So I'm going to use that information to help me here. So if I'm going to use 50, then I should set up tangent 50. Again, I'm going to look for opposite, which I don't know the opposite side. So x, but I do know my adjacent side is 20. So that's how I would set up that problem. Alright, so what am I going to do to both sides? Multiply by 20. Good. Alright, so I would do 20 tangent 50 degrees. So I would do, let's see, 20 tangent, oops. Alright, which should give you about 23.84. So that gives me this side over here. So last step is finding the measure of the hypotenuse. So we would do 20 squared plus 23.48 squared equals c squared. This side is left blank because this is c. Always this is c. So we would do 20 squared okay, and then we would add those together. And then your last step would be to find the square root of that number. Oopsie. Alright, so that would be about 31.19. Okay, so these are my examples. We're going to glue this in, but just 1 second so I can tell you what this is. This is not going to be something we work through. What this is it's an answer key actually. So rather than going to your calculator, like say you're trying to figure out a problem and you need to know what the sign of 50 is, I'm going to go to 50, go to sign, that's my answer. So rather than typing it into the calculator, these are already kind of answered for you, okay? So these two are going to go into your journals. So we're going to glue those down. Eli, you can go to the restroom now. Okay, real quick, let's do this. All right, so when it's asking us to find the measure of an angle, okay, notice on here we see this little weird symbol right here. This is called theta. All that means is a missing angle. Like instead of putting x or y or z or variable, they're using a theta, the theta symbol. So when I see that, that means, okay, that's what I'm trying to figure out. So basically, I'm trying to figure out the measurement of angle A right now. Okay? So I'm going to use the info given. 13 is my hypotenuse, right? And then this would be considered my adjacent side to theta, because the opposite would be over here. So if I look at my notes, what involves A and H? C, right? So good, Toa. Alright, so that means that I'm finding cosine. So if I want to find the cosine of theta, all I have to do, remember, so Toa, I'm just going to put the adjacent side, which is what number? 12, over the hypotenuse, which is 13. And that's my answer. Okay? Now, what you could do here, if it's asking for a degree measurement, okay, then you would actually work it out and divide it. So 12 divided by 13. Oh, hold on. We'll just leave it as 12 over 13 for now. Okay, so basically what we did on the first example, this is what we're doing here, okay? So now I'm going to move down, and this one is asking for the measure of each side, so this is different, okay? So again, I'm going to use the information given. If this is my angle, I need to identify what is x on the triangle. Hypotenuse, good. And the 11 would be my, would it be opposite or adjacent? Good, all right. So again, we have another one that's using adjacent and hypotenuse here. So that is again going to be cosine. So the cosine of 37 equals adjacent, which is 11, over the hypotenuse, which is x. So in order to cancel out, excuse me, 11, I would multiply by what? 1 over 11, yes, very good. All right, so both sides need to be multiplied by that fraction. So in my calculator, this is what I should be typing in. So 1 over 11, which I would put, let's put some parentheses around that. And then I would do cosine of 37. Alright, last example.